We're the Missouri University of Science and Technology ACI student team, and this is our submission for the fall 2021 EcoConcrete competition. In this presentation, we'll be discussing both of our mixed designs, the basic and alternative cases, the process we went through for material selection, and what the students learned overall throughout the competition.
So to begin in our design phase, our team recognized the requirements of having a minimum of 75% total mass of the mix going towards the aggregates. Additionally, however much we include, we would have to be equal between both cases. Knowing that our improvement depended on cementitious materials, we decided to have the bare minimum of aggregate to have the most amount of cementitious material to replace. After looking at our options and comparing with the data in the calculation tool, we chose coal fly ash for lower environmental impact per kilogram and silica fume for improved durability.
Here we have our base case scenario design. This included 3 different material categories: cementitious materials, aggregates, and water. Included in cementitious materials, we used type 1 Portland cement, which made up all of the cementitious materials. In aggregates, we used crushed sand and crushed 5 to 10 millimeter aggregate. And then for water, we used tap water. This formed a mix that we could compare the alternative case to, so that we had an idea of how much environmental impact reduction there was between the 2 cases. So the alternative case design also had the same material categories: cementitious materials, aggregate, and water. However, the cementitious materials contained not only cement, but fly ash and silica fume as well. 40% of the cement was replaced, with about 37% of the cement being replaced by fly ash and around 3% being replaced by silica fume. The total amount of material remained the same, though, between both cases per the design requirements that were needed for the 2 mixes.
So totaling our results with the best case scenario as reference, we put them both into the EcoConcrete calculation tool, and our average environmental impact reduction was 15.1%. Our best improvement came in the global warming category with a 29.4% reduction, followed by the fossil fuel depletion impact at 22.6% reduction, and ozone depletion with 21% reduction. Ecotoxicity had a minor improvement of 4.2%, and unfortunately, the carcinogenic category increased by 1.6%. When it comes to identifying the major factors affecting the life cycle assessment, in the cement substitution, coal fly ash was definitely an upgrade from Portland cement for its universal reduction in all environmental categories, allowing us to achieve such high improvements. With transportation, the additional environmental effects stacked on top of what was included with coal fly ash and silica fume. Lastly, the greatest factor was the silica fume. Although it was a primary ingredient in boosting our durability, it worsens the environmental effects more than the Portland cement it replaces, such as increasing our carcinogenic impact.
So in conclusion, students learned that in order to achieve a balance between environmentally friendly and durable concrete, many factors had to be taken into consideration. Primarily, we looked at transportation distances from the place these materials were being produced to our university, as well as how these materials were produced and how that affected the environment. Students learned a lot through this process. We even learned about materials that we ultimately chose not to use, including things like slag and admixtures, both because of their environmental impact and their distances from our campus. We were able to be creative in the alternative case and really explore the research sources that Missouri had to offer, and even more specifically, what the surrounding towns around our university had to offer. It was really a great way to learn about production in our area, And so while we were doing this, we were able to build a better understanding of what sustainable concrete of the future might look like, and how we could be a part of it. So this has been the Missouri University of Science and Technology Team ID Minor. And thank you for watching.